Good morning, guys! Today we're going to continue on with our work with powers. And don't forget our last rule with powers. If you are multiplying two exponents that have the same base and multiplication between them, you can add those exponents. And we practiced that a few times. You guys did a good job with your homework for that. And what we're going to do is we're going to add a rule to that and see if we can do a couple rules at once. So let's start with this one. Let's say that we have x to the a to the b. So the power here is being raised to a second power. Well, let's look at what that could appear to be by taking a normal example. So let's do x to the third raised to the fourth power, okay? Now you got to remember what this is saying. This 4 is telling us that everything inside the parentheses is going to be multiplied by itself 4 times. So that actually means instead of x to the third to the fourth, what I have is x to the third times x to the third times x to the third times x to the third. And at this point, you could actually just use your addition rules, right? Because these are a whole bunch of things being added together. And you could say, well, that's just 3 plus 3 plus 3 plus 3. And 3 plus itself 4 times is just 3 times 4, 12. But you could also take this a step further if you're like, well, I don't want to use those addition rules. Well, then think about it this way. Each one of these is just x to the third. So that means that it's x times x times x. And I could just write it out that way and count them up. So I have 4 of these being multiplied together, and each one of these represents 3 x's being multiplied together. And that means that here I could count them up, since powers just tell me how many times I'm multiplying the same number by itself. I'd have 3, 6, 9, 12. So that's x to the 12. So that's actually like 3 different ways to see the same expression, or 4 different ways because we have the very simple one here. But in the end, what it boils down to is you are going to end up multiplying these two numbers, these two exponents. So I get x to the a times b. And a lot of times these get confused and people will do addition in between these. But remember that exponents are more powerful than the multiplication that we had above. So here we had multiplication in between and we went down to addition. Here we have powers, which are pretty strong, and we're going down to multiplication, just like half a step below. So let's practice this rule just a couple times before we start combining rules. And here is our first example. We've got 3 to the third to the second. 3 to the third to the second is the same as 3 to the third 2 times, or 3 to the 3 times 2, or 3 to the 6. And you can put both those into your calculator to see if they work. We can do the same thing with p to the fourth to the fifth, and that's just going to be p to the, well, since it's a power being raised to a power, it's going to be multiplication, so 4 times 5, or p to the 20th. Now our next rule is going to be kind of like added into these. When we are talking about powers here, q does have a power, and that power is 1. So that means I'm doing q to the 1 times 5, or just q to the 5 here. And that brings us to our next one. What happens when you have more than one thing in the parentheses? Well, I could give you the rule for this, but you can honestly see it just by writing this out as you can write out exponents. So negative 6 times b times itself, right, this whole thing is being multiplied by itself 2 times, is going to be negative 6b times negative 6b. And since this is all multiplication, I can write this in any order I want, which tells me I've got negative 6 times negative 6 times b times b, or negative 6 squared. Make sure you have parentheses around that, because otherwise it ignores the negative, times b squared. Now looking above, can you see what happened here? Well, what happened here is that the 2, when it's all multiplication inside, gets distributed. Now be very, very careful. It can only work if there's only multiplication inside. And here, while we do have a minus that's actually negative sign, it's not in minus and subtraction sense. So that means that I can distribute this power. And that does give us a final answer of negative 6 squared times b squared. And just to simplify that further, you could always do negative 6 squared, which is a positive 36 times b squared. So that means when I get a problem like this where we've got 4y times z, I can just distribute that 3 to get 4 to the third, y to the third, z to the third. And taking it even a step further from that, well, what about this one where I've got this 6 and this 3? Well, don't forget that it distributes. This is going to give you 2 to the 6. Remember that 2 is just a normal number. Okay, it's not an exponent, so I'm not multiplying here. I still have a power. And with this next one, I've got w to the third to the 6. That's 3 times 6 because I've got a power to a power. When I simplify this, I could find out what 2 to the 6 is, or I can leave it like that, and I prefer to leave it like this. And w to the 3 times 6 is going to be w to the 18th. And I would be done. Now, don't forget our previous rules, okay? And all of this that's going on, you still have to remember that you can combine powers in multiple ways. So here, if I'm asked to simplify this, I'm going to start by getting all of my numbers sorted. So I'm going to start by getting the 3 and the 2, our normal coefficients, the numbers in front of the variables, in the front. And I'm even going to cross them out, okay, so that I remember that I've moved them. And remember, I can move them because as long as everything's multiplication, you can do it in any order you want. The next thing I'm going to do is I'm going to get my x's by each other. Notice that my signs here are still multiplication. So now I've got x to the 7th times x to the 5th. Now I'm going to look back at my rules. I know that I have a rule for exponents, but if I go to the top of the page or my notes from yesterday, I know that if I'm multiplying two powers that have the same base, their exponents get added. So this x to the 7 and x to the 5th is x to the 7 plus 5 or x to the 12th. And if I look at 3 times 2, well, don't overthink things here, okay? 3 times 2 is still just 3 times 2. There's no special exponent rules here because these are not exponents. These are normal numbers. So 3 times 2 is just 6. And that gives us our final answer of 6 times x to the 12th, or you could just write that 6x to the 12th. And by the way, just like before, you can pick any number to put in for x, like the number 2, and do 6 times 2 to the 12th, and it should give you the same answer as if you put 2 into this expression. 3 times 2 to the 7th times 2 times x to the 5th will give you the same answer. So that will tell you if you did it right. Alright, so now this leads up to the final one, which is when it gets a little bit harder, okay? We're going to combine all of this mess. There's a few things to remember when you're doing this sort of equation. First, don't forget that you have to take care of parentheses first, because they're first in order of operation. So see if you can simplify within the parentheses. Well, 4 times x squared I can't simplify within, but I don't have any addition signs. I only have multiplication. That means I can distribute this power of 3. Don't forget this is a power of 3. That means that I'm going to get 4 to the power of 3, right? It used to be 4 to the 1, now it's 4 to the 1 times 3, 4 to the third. And I'm going to get x to the 2nd to the 3rd. And x from to the 2nd to the 3rd is just x to the 2 times 3, or x to the 6. Remember, now we have a power to a power, so we're back into the multiplication realm. Here, I can drop the rest of my problem down. I've now taken care of this part, so I just have to put x to the 5th at the end of my problem. Next, I look for things that I can combine. Well, 4 to the 3rd is still just a coefficient. It doesn't have simplification, except perhaps just figuring out what 4 to the 3rd is. But don't forget that as long as you have the same base and multiplication between, you're allowed to add those exponents together, because this is just 6 x's multiplied and this is 5x's multiplied, making it a total of 11x's multiplied, or x to the 11th, or x to the 6 plus 5. So that gives us our final answer, 4 to the 3rd times x to the 11th. So you can see how all these rules are going to combine as we keep moving forward. And I highly recommend that you keep a paper ready that has just the simplified rules. Like, you can maybe use an example like this: x to the 3rd to the 4th is equal to x to the 3 times 4, or the 12th. And you can maybe do one like this where you've got x to the a times x to the b equals x to the a plus b, or give yourself a different example if you like doing this with like normal numbers. You could do something like this to get your hint or your rule written down. Okay, I want you guys to do some book work that you guys can find on Classroom. Don't be afraid to ask questions. I will be online from 10:30 till 11:30 today for in-person Zoom questions, but around all day if you have them. And I hope you guys enjoy the day off tomorrow.